class. My name is Stephen Soti, and once again I welcome you to today's lesson. Today we want to talk about remote sensing. Remote sensing. Are you aware that you can be here and then get information about a distant object? In astronomy, researches are being conducted about space and not necessarily going there. All these and more are applications of remote sensing. What is remote sensing? Remote sensing is the science of obtaining information about objects and areas from a distance. Obtaining information about objects and areas from a distance, typically from aircrafts or satellites. So you get information about a distant object using satellites or aircraft. In the military, information are being obtained from the enemy's camp by sensing using aircraft. Sometimes satellites take pictures of that far away enemy camp, which are being analyzed by the other opponent for various strategies to be made. How does it do it? First of all, the remote sensor senses. It must sense and then record reflected or emitted image or energy. The energy will be in the form of radiation, and then process it, analyze it, and then apply it as information. So remote sensor senses and records reflected and emitted energy, and then processes it, analyzes it, and apply that information. So just as you can see, we could be on Earth here and have all the satellites gather information from bodies here and then either emit it or reflect it for processing and analysis to be done on it, and then it is being converted into information for other applications. Why remote sensing? In research, remote sensors are used for systematic data collection. And once again, we can have remote sensing applied in astronomy to take data of bodies up there, stars from galaxies and so. In geology, we can take information and make measurements from deep down the earth crust using the application of remote sensors. Remote sensors have a repeatability characteristic, and that explains the ability of the sensor to provide same results under the same circumstances over and over again. So we can repeat the same sensor for the same circumstance at any other place. It also have a global coverage where it get to normal eye cannot get to. It can take a very information or data from a very big perimeter. So the top right there, we have the map of the world. And we have satellites there that take data, okay, about it every 16 days. Takes data about the whole world, the whole Earth or world, every 16 days. And from 1997 to present, there is information about it. You can read, you can go to www.glad.umd.edu/ard/home to read about that data. Then it is inaccessible. We can be able to access inaccessible areas, places that we cannot get to, like the example in astronomy, in deep oceans, where maybe you and I cannot get to. Remote sensors, with the application of remote sensors, we can be able to get information from that deep ocean. We also have it being used for multi-purpose information systems. Who uses remote sensors, and then why? Remote sensors, I would say, can be applied in every sphere of life. For example, in geography, where the geographer who wants to look for changes on the Earth's surface would apply it. A forester seeking to know what or which plants does well per season or those likely to be diseased. An environmentalist who wants to detect and identify the movement and amount of pollutants like an oil slick in an ocean. I spoke about that. A geologist prospecting available mineral. How does it do that? It sends radiations deep down and then capture the characteristic, the coarseness, or the characteristic of the land at that particular, of the soil at that level or profile. And then picture of that is being compared with the standard, and then we are able to prospect. A farmer wants to tactfully fight pest and disease effect on his crops, can apply that. A captain of a ship who needs to find the best route applies remote sensing. A firefighter who sends out his crew based on information about the size and movement of the forest can also apply that. As well as an urban planner who wants to map and monitor land coverage, land use, and morphology. So we use drones mostly in this application. Types of sensors. Sensors can be classified in terms of the image capture resolution, the sensing technology, or the typical altitude. From land to space, you realize that we have class or types of sensors everywhere. On Earth, we have cars, and cars who uses sound sensors. In terms of topography, we have cars here. We have these dishes, communicative satellites. We have the tethered balloon. We move to the stratosphere. We have stratospheric balloons. We have airborne instruments like the planes, which are kind of between, let's say, 5 to 30 kilometers away from Earth. We have HD videos, and then we have these sensors, okay, major satellites located about 500 kilometers away from Earth. So that's to say that the type of sensors can be classified in terms of altitude, the type of technology that is being used, as well as the resolution, how bright the image that has been captured from that far place is. Remote sensing processes. Remember, we said a remote sensor must first of all be able to sense, right? Must be able to sense and record reflected, very, very important, reflected and emitted energy. So first of all, there must be an energy source at A that sends or transmits radiation in the form of electromagnetic waves. These waves or energy interacts with the atmosphere and then reaching the target at C. Some are being sent into the ground or transmitted through the atmosphere to the sensors. And then based on, we also have a standby satellite here that tells us or tells the ground or workstation if the information or if the sensor is right in position or not. So it's kind of a checker. Now, information or radiation from the heat source that reaches the target, and then from the energy source that reaches the target, and then reaching the sensors are being sent to the ground for interpretation and an application. I want to take each one of them and talk a little about. So we said that first of all, there must be an energy source, okay, which provide electromagnetic energy to the target of interest. This electromagnetic energy interacts with the atmosphere at B, and upon reaching the target, it also interacts with it, and then transmitted to the sensor at D, back to the workstation, where data get processed into imagery in the form of hard copy or digital, in other words, soft copy, for interpretation and analysis to be done. Now the processed image gets interpreted digitally or visually to extract information about the target, and then applied for solving crucial problems. Applications of remote sensing. Remote sensing, if you go to the national security, we have a whole unit for remote sensing, and that's for targeting, disaster mapping and monitoring, damage assessment, weapon monitoring, homeland security, navigation policy making, telecommunication planning, and coastal mapping. All these are ways by which the national security applies remote sensing. In medicine, remote sensing is applied in detecting cancerous tissues in the human body. Have you ever taken an X-ray before? That's an example of an application of an example or application of remote sensing. In the exploration of terrestrial bodies, remote sensing is applied. Recently, NASA sent a Mars rover to Mars. That's an example of remote sensing. In astronomy and cosmology, we are able to receive, in terms of research, we are able to receive data from galaxies and stars, and then the map of the skies. In the Big Bang, we are able to tell the age of the Earth, or be able to tell the age of the universe. And that's an application of remote sensing. In meteorological applications, we are able to tell changes in the climatic or weather. And that is also an example of an application of remote sensing. In geology, we are able to sense and detect certain minerals at various soil profiles by applying remote sensing. In agriculture, we can also apply remote sensing to detect pests and diseases, soil mapping and monitoring, global crop programming, cropping system analysis, horticulture crop estimation and monitoring, and so on and so forth. Thanks for watching. Watch out for the next lesson.